Hey everybody, welcome to Nerd Central. I'm your host, Mr. Beebe. I just wanted to go through a few of the questions from the review section for you, just to give you a set of extra examples for explanations for those of you who need it. This one is talking about number 1 here, number 1A, and we're just trying to match up functions with their graphs. And so this is the graph that you're given for 1A, and I'm just going to point out a few things to you, and we'll sort of look at what they mean. First of all, we notice that the graph goes from, quadrant 3 to quadrant 1. Okay, that behaves just like a y equals x graph, which also goes from quadrant 3 to quadrant 1. Okay, so that's the y equals x. So what that tells me is that because it goes from quadrant 3 to quadrant 1, that means that my function, whatever it is, has a degree of 3 or 5 or 7. Okay, obviously not a degree of 1 because that'd be a straight line. So a degree of 3 or 5 or 7. Now looking at the options you have to pick for number 1, there are no degrees of 5, which is why I'm saying it's a degree of 3. Okay, so it has a degree of 3 and it has to have a positive coefficient, because it behaves like y equals positive x, not y equals negative x. So it goes from quadrant 3 to quadrant 1, so it behaves like y equals positive x. It has, it's most likely a degree of 3. I just got to try to find that graph that does that. Now for that particular question, there's only one possible answer, and that would be x cubed minus 3x squared plus 1. Nothing else really matters. These numbers don't really matter for this particular example. However, if you wanted to confirm, look at the y-intercept. When x is 0 here and x is 0 here, all you're left with is y equals 1. That's my y-intercept. Just as a little check to do for yourself. Okay? So that's kind of an extra example for how you look at matching up functions with their graphs. I'll do a couple other ones here too.